Hello, everyone. This is Alessandro Premier from the Future City Research Hub, School of Architecture and Planning, University of Auckland. And today I'm presenting a study entitled Smart Solar Urban Furniture, Design, Application, Limits, and Potentials. This is a preliminary study, which is part of a larger investigation project with the aim of co-designing a smart solar urban furniture in Auckland. The research will start in 2021, and it has been funded by the Faculty of Creative Arts and Industries of the University of Auckland. Goal of this preliminary study was to investigate a set of international precedents to understand their potentials and limits. But let's start with a definition. A smart urban furniture is a design networked furniture that is equipped with an intelligent system or is controller operated with the user's data and energy sources. In particular, in this study, we are looking at solar urban furniture, thus urban furniture integrated with solar technologies. The three main criteria of this study, evinced by literature, were the architectural integration quality, the context sensitivity, and the system visibility of these objects. The system visibility assesses the perception of solar system from the public spaces. It can be defined as a close visibility from a urban perspective or remote visibility from a far observation point. It is basically related to the visual impact of the solar panels in the design of the object. This is strongly related to the architectural integration quality. This means that the solar system has to be designed as an integral part of the architecture or the urban settlement in which it is located. Geometry, materiality, and modularity are assessed within this framework. A lower system visibility, so a lower visibility of the photovoltaic system, is generally related to a higher architectural integration quality. Instead, the context sensitivity is the socio-cultural value of the urban zone where the urban furniture is located. Historical centers are generally ranked as high sensitive areas, while industrial areas are low quality suburbs, or low quality suburbs are usually ranked as low sensitive areas. So we classified smart solar urban furniture into canopies and pergolas, kiosks, carports, bus stops, solar benches, solar trees and solar street lights, and other experimental objects. 80 case studies were investigated in this project, and here are some examples. The first one is the North Sydney coal loader, which is part of a large project of urban regeneration. So the context sensitivities is quite low. Solar panels are distributed only on a small portion of the canopy, and they are almost flat. So the visibility of the panels is still high, but they constitute a part of the roof of the structure. And since the panels are not distributed on the entire structure, they don't change the overall perception of the architecture. So carports for electric cars are becoming more and more popular. Also in Auckland, with the request to the council of people who wants to install their own carports in their garden. They will be an important topic in the future of all cities in the world, especially also for Auckland. This was a temporary structure with thin film solar cells integrated on a membrane. So visibility of the cells was very high as they covered almost the entire surface of the carport. But however, solar cells were custom designed according to the form of the object. And context sensitivity was variable according to the place of installation. Anyhow, the spatial form and removability of the pavilion was suitable for different contexts, even for temporary installation in historical centers. This bus stop was designed by MIT for the Historical Center of Florence in Italy. It is an interactive object with smart maps and touch screens with the real-time information of public transportation and traffic. It was designed as a single piece of curved glass where all the technologies were integrated in. So the transparency of the structure was chosen to be adapted to a sensitive historical context. And so the design was particularly successful from that point of view. There are a lot of commercial products of solar benches, in different cities of the world. Although benches can be designed for special contexts, the integration of solar technology seems to be more difficult than other options. Often, they are designed in a small pavilion-like structure because it is very difficult to install solar panel on a bench where you have to sit on. Tree-like structures became quite popular in the last few years. The goal is to utilize the minimum land for maximum solar power generation. They are often characterized by a high visibility of the panels. A particular achievement of this specific project, designed by Ross Lovegrove, a British designer, is the form of the leaves, which are not just holding standard solar panels, but are custom designed according to the overall design of the structure. This was conceived as a piece of furniture to be adapted in different contexts. And version 2.0 of this project integrates a number of functions like free Wi-Fi distribution and IoT services. Experimental projects are also very, very important in this field of research to understand alternative ways for achieving the goals of these objects. This project is characterized by floating solar balloons capable of capturing the energy from the sun, even in those urbanized areas where high density would make the positioning of traditional solar panels practically impossible. The project is inspired by NASA, and they also build some prototypes of this project with very cheap solution. Majority of the projects investigated were canopies and pergolas, as it is visible from this graph. On the y-axis, you can see the number of case studies. Results of the preliminary study show that a higher system visibility usually leads to lower architectural integration quality. And in particular, issues have been identified in commercial products like solar benches, solar trees, and street lights, where the maximization of solar power generation often leads to a less integrated design. Potential of these objects are well known. Charging docks for smartphones or electric cars are well known. Free Wi-Fi distribution, information screens, as we have seen before. But even temporary shelters for homeless people, for instance. Education on renewables, energy savings, of course, and very important, big data collection. Identify issues are stealing and vandalism, and education from this point of view is very important. And of course, visual impact is also a big issue, especially for standard solar panels. When we are using standard solar panels and they are really not designed for being adapted to particular structures. In fact, lack of design is another issue, particularly in some commercial products. And then urban morphology is, of course, very important for problems related to overshadowing. So specific areas have to be carefully selected for the installation of these products. In this picture, you can see a preliminary sun study and a cumulative solar radiation analysis carried out for understanding optimal location of temporary and permanent solar installation in the University of Auckland City campus. For what concerns Auckland, studies already demonstrated that suburbs offer the best opportunity for exploration because of the urban morphology characterized by lower buildings and more even uniformity and distribution of the built environment. So this leads to less problems related to overshadowings, of course. In conclusion, next steps of the project involve the creation of a community of interest composed by relevant stakeholders around the specific project of a smart solar urban furniture in Auckland. Contribution from different perspectives and expertise are more than welcome, and my contacts are below. Thank you very much for the attention.